Hello everybody, and welcome to this presentation from SewerAI on leveraging AI, computer vision, and cloud computing in sewer condition assessment. Let's get started. A little bit about me. My name is Eric Sullivan. I'm the Director of Business Development here at SewerAI. I'm also a NASCO, PACP, MACP, LACP trainer, and I've been doing that since 2012. And I have over 14 years of experience in the Trenchless technologies industry. SewerAI was formed in 2019, in February of that year. We are a growth stage startup. We're based in Walnut Creek, California. And currently, up to date, we've done over 1,100 miles of pipe assessment so far using our AI tools, which I'm going to share with you today. A little bit of an overview on the presentation here. We're going to cover what types of problems in the industry we're solving with this technology. What is AutoCode? What is Pioneer, which is our cloud-based platform for inspection data management? We'll go over some of the integrations that are relevant that we've accomplished with our Pioneer platform. And then I'll show you a quick end-to-end demo of the platform as well. Quickly review some of our current partners and projects in North America, as well as quickly sharing 2 case studies and covering a summary of the different use cases that we've identified for this technology. So first, let's talk about some of the issues that we identified with current conventional workflows, specifically the manual workflow. What we observed is that in our industry, the most common method that folks use for doing CCTV inspection is a workflow that you could call capture and assess. By that, I just mean that the operator who's driving the transporter with the camera equipment through the pipeline, at any point in time where they see a condition in the pipe that would need to go on the condition assessment report, they're going to stop the transporter, they're going to take their hands off the controls, they're going to separately enter in a software program, what that observation is, hit save, wait for that to appear on screen, and then once that disappears, they continue forward, and over again, they do that process. Again, it's a manual, real-time data entry type of process. What we noticed about that is that if you were to measure the average amount of time that a camera truck is going to spend at an access point conducting an inspection, 2/3 of that total time, the camera is not actually moving forward in the pipe and no new data is being collected. I think it's important to mention too that while the camera operator in the studio of the truck is performing these tasks, there are other people on site that are waiting for them to complete those tasks, whether it be assistants, helpers, laborers, or traffic control equipment and people set up. And then also importantly, probably a vac truck is at the other access point there for flow management and support. So a lot of expensive equipment and several other people on site, again, all waiting for that operator to complete those manual tasks. Manual condition assessment is hard. That is certainly something that I've experienced as a NASCO PACP trainer. 2 days or maybe 3 days with each group of new students to certify them is really not enough time for anybody to become a master. We tell people that we certify folks as novices, and the idea is that they take that manual and they develop themselves over time. But there are huge differences in terms of one operator to the next and the level of quality. And what we're asking operators to do is basically be an engineer while they're on a job site having to manage all these other tasks at the same time. The other thing that we found is whether an operator knows what they need to know or not, they're still a human being, and there's still a lot of limitations to how human beings are able to reliably find what's in the image. A study in Germany from 3 years ago found that operators are missing up to 20% of defects in the pipe inside of that manual workflow, and that can be significant if you consider those to be like structural defects. And then the other thing that's also important to get is that the larger the project or the more different operators are contributing reports to a project, the wider degree of variation you're going to get and the less consistency you're going to get or reliability in your data, just due to the fact that different individuals have different subjective interpretations of the same video. We also saw that there was just a lot of data management difficulties that folks in the industry were struggling with. So we saw folks having to travel to a physical location to hand off a hard drive to someone else to submit a project deliverable. We saw folks having to over-rely on things like Dropbox to transfer large video files, maybe just to watch them one time, and also the way that that impacts the approval process for projects or for contractors getting paid or for engineers having access to the information that they need to make those critical decisions. And so what you're seeing here is an example of AutoCode. This is an example of the raw AI output. Not really part of the deliverable per se, but we think this communicates what's going on with our AI technology. So what you have here is a variety of different AI models have inferred on the video. So each AI model is looking through each and every frame in the video, and when an AI model sees in an image that there's a condition in the pipe that it's been trained to detect, it's going to bracket that part of the image with this green bounding box that you see here. And depending on which model made that prediction, that's also going to determine which label or annotation is made alongside the prediction. What you're also seeing is a set of numbers in parentheses next to that annotation, and that's just a confidence score that the AI outputs for each of the predictions it makes. And that's important for two reasons. One is that in our process, the AI is only an assistant and assisting a technician in the finalizing of a PACP report. So, a person makes that final determination about an actual condition on a report. Secondly is we can simply adjust, increase the sensitivity or decrease the sensitivity of different AI models by adjusting the confidence threshold as well, which we think is important. And as you can see, there's a variety of different AI models that we are utilizing in our processes. We have about 60 different AI models currently that we are training and developing, each one looking for a specific condition in the pipe. So one of the benefits of AutoCode is that it enables a much simpler and more efficient workflow in the field. So what you see on the left is an example of a very traditional standard type of inspection where the operators manually input every single code as they crawl through the pipe. On the right, what you see is the AI-enabled workflow being implemented here. So the operator is able to traverse the pipe at a much higher average speed in the pipe. They are still going to turn the camera at certain defects or conditions like a lateral or anytime they see a hole or a void in the pipe. But the thing to get is that the CCTV camera is capturing 30 frames per second, and the AI only needs one good frame to make all the predictions that we need it to make. So the operator does not have to take their hands off the controls, and they can film the pipe in a much more efficient way. And that does equate to a much higher average speed in the pipe and overall much higher production over the course of a workday. So here's a short diagram meant to show the process or the workflow as it relates to the data for customers that use our technology. The first thing I'll say is that the inspections themselves are all captured in the field. The operator in the truck is going to enter in the header data, and they're going to verify that they're at the right location. They've identified the GIS or asset ID correctly for the pipe they're inspecting. They're going to hit record. They're going to use that method that we described earlier. They're filming the pipe, and they're not doing any data entry while the camera's in the pipe. Once those data sets are uploaded to Pioneer, then we initiate AutoCode inferences on them. That can take between 25,000 and 50,000 linear feet per hour as far as AutoCode's processing speed. Once the AutoCode inferences are done, then the team internally here at SewerAI of NASCO PACP certified technicians is going to get alerted that there's a number of review tasks to complete. They're going to review all of the AI output, all the predictions it made. They're also going to review the raw video data as well and make the final determinations about which PACP codes go into the inspection report. So what you end up with is two things. You end up with a customer submittal that's NASCO standard deliverable that's really no different than the current deliverables that we see today, other than that AI has made it more consistent and more rigorous and more accurate. And secondly, you end up with a bunch of additional images that a person has reviewed and confirmed, and you can give those back to the AI so that it's able to add to its reference library of images. And the performance of the AI tools improve the more projects we execute and the more further examples that we're able to give it. By the way, in terms of integrations, we've got our software PACP certified for import and export. We've also reached a licensing agreement with NASCO, enabling us to use the PACP defect catalog in our internal AI training process and our AI processes for doing projects. We also are in the Esri partner network for startups as it relates to geospatial data. And then our system is an API-based system, and all that means is that when folks want to integrate with us, we provide with them the different resources that we have in terms of what type of code you would need to write to communicate with our platform and also extract data out of our platform as well. And we have more planned integrations ahead, whether they're related to GIS or CMMS. let's look real quickly at the Pioneer platform. I'm just going to walk you through a quick demo here. So firstly, you go to the website, pioneer.sewerai.com, and then you click the blue button in the middle, try it today. That brings you to a login page. If it's your first time, you'll just select an email address, you'll verify that email, and you choose your password. Or alternatively, you can utilize a Google-powered email account and link that to your sign-in and do it that way. So once you're in the platform, it's going to look a lot like this. You're going to see a lot of inspections, and then you're going to see several status keys. What we have here is a way to see how many total videos have been uploaded, how many of those videos have been auto-coded, etc. The other thing, too, I'll point to is that there's also a chat feature where you can get support immediately. This reaches us on our mobile phones here at SewerAI. You can talk with us. We can set up Zoom or Teams meetings to screen share, or you can look up some of the resources yourself. Here, we're just looking up how to upload, and there's a tutorial video that you can watch to do that. But I'll show you how to do that right now. So to upload, it's fairly simple. We wanted to make it so that folks can easily import large batches of videos and databases at one time. So all you simply need to do is select the parent folder, which contains the MDB, Microsoft Access database, as well as all the videos that were captured in the field. In this case, there's one MDB and 2 videos inside of that packet in that folder. So I can then click View Files, and what it does is it reads the database up front. Okay, and then you can verify that you got the right videos in there. It's going to tell you how many linear feet of data it contains, as well as how many gigabytes of data it contains. You click Upload, it brings you to the upload interface, and you can see that progress bar, and it can run in the background while you're doing everything. Now, one of the things about the Pioneer dashboard homepage is that it's got a very dynamic way of looking up inspections. Here you can search for specific PACP codes, multiple codes at one time. There's also that quick button for grade 4 or 5 to show you any surveys that have an overall rating of grade 4 or grade 5 as well. And here we're going to look in the video player just to see what it looks like to review videos and to make observations, etc. So first thing I'll say is that this is a very customizable interface. This is all happening inside a Google Chrome browser, by the way. You can actually make adjustments to the size or position, orientation of any of the different windows. So here's the video playback window. I can make that larger or smaller, or put it in whatever quadrant of the screen that I want. In the middle there was the header data, just the basics of the inspection and the asset inspected. I can now speed up the video as well too, as needed. Pause the video, and then up top you can see the different PACP observations that were made. In any of these windows I can actually expand out and put in a separate monitor if I'm using that in my setup. But here's the different PACP observations, right? And I can collapse that back down. It's going to go back to where it was before. And again, I can expand that up. So a couple things here. We're going to show you how to add observations. Quite simple. You just click the plus button icon, and then it brings you to whatever part of the video was playing at that point in time. And the other thing too is that if you hover over any of the PACP codes, it's going to bring up a tooltip and tell you the English name of the defect, because not everybody has all the PACP codes memorized. Anytime you want to delete an observation, you saw what I just did. I clicked the trash can icon. So everything's always saving constantly in real time in the platform. Any observation you add or subtract, it just automatically saves itself. Okay? And then you can navigate the video by way of those different observations. Here is where you can press a button that's going to save that URL to your clipboard. And you can send that to somebody else on your team, whether it be through private message or through email. And anybody else on the team that has, the login credentials for view mode is able to open up that video as a web browser on their end and see that part of the video playback immediately. Okay, and then you can either look up other inspections from your query that you had set up earlier, or you can go back into the home view and see everything. So to run autocode on an inspection that hasn't had it run on it before, you simply click that inspection and then you click Confirm Autocode. Now, when autocode's been run on a video, this is just a bit of a look under the hood to what our internal labeler or PACP review technicians are doing. So they're using the AI as a tool to confirm certain observations. You can see here those different bounding boxes are the predictions that were made by the AI of what was in the pipe. Now, to download data and pull data off of the platform, we made it pretty simple. So you just select the inspections as long as they've had autocode run on them or they're complete and don't have any NASCO PACP errors or missing required fields. You can select them for download, and you're going to select which version of NASCO you want to use, whether you want to include snapshots, PDF reports, videos, and we'll also re-render the videos to include on-screen annotation as well as computer-generated audio narration. Before you finally do the download, make sure that you've toggled the imperial versus metric depending on whether you're in the US or Canada, because you can do that at any time on our platform. Toggle between metric and imperial. It'll do that conversion instantaneously. And then you just pick a location on your machine, folder location that you want to download it to, and then it downloads. And you can see a progress bar there. Anyway, that's the ins and outs of the Pioneer platform in the short version of it. Hope you like that. So here's just a quick look at the different places in North America where we've got active projects going and where our various different customers are located. Just show you a quick view of the different companies that we've had the opportunity to work with over this last year since we brought this technology to market. I'm going to share. So here's a quick example of one of our first projects as a case study. We were working for San Francisco Public Utilities Commission, and we brought this technology to them about a year and a half ago, and they identified a use case for us, which was a situation of that they had about 1 million linear feet of lateral inspection data, which was about 52,000 individual inspection surveys, and they'd been given this data by different contractors who were doing cross-bore safety inspections in the city of San Francisco. However, none of those inspections had been done with any condition assessment coding on them. So as the sewer owner, they didn't really know, based on this data, which pipes that they owned, and they do own the lower laterals in San Francisco, which pipes that they owned contained different O&M defects and structural defects, which pipes needed to be cleaned, renewed, or dug up and replaced, anything like that. So they saw it would be valuable for them to add NASCO PACP or really LACP coding to this data set. However, they saw that it would take them about 8,800 total hours to review and manually input those codes into the data, and that's about 10 years of one individual's life if it was just a one-person team. And for them, these were engineering hours, and it would cost them over $1 million to do that. So we did this project for them in a matter of months, not years, and we did this at a rate of 25 cents per foot. So we effectively saved the owner $750,000 and several years of engineering time by leveraging AI. Now, for us, this was beneficial because we saw that we could show that the technology was hardware neutral, that it doesn't require high definition data, and also that it can work on CCTV mainline and lateral data too. So another case study I'll share with you real quick would be how this workflow change and this technology really benefits operators in the field obtaining more CCTV production footage. So we have a contractor that fulfilled a project in 2019 through traditional conventional workflows, just the same that you would expect them to do had they been doing this 10 years ago, where you got an operator manually coding everything. Now, in 2020, they won a very similar project about 10 miles to the west of the 2019 project. Very similar in scope, too. This is in vitrified clay pipe, about 12-inch diameter and less, clean and TV, low-bid municipal project. And everything was the same except they changed their workflow and they adopted the AI-enabled workflow that we described to you earlier. Other than that, the project was carried out by the same individuals in the same trucks and outfitted with the same type of CCTV equipment. And the result was essentially a doubling of production when you compare one to the other. They were able to accomplish almost 2,700 linear feet per day of average production compared to about 1,352 linear feet per day in the 2019 project using traditional methods. So the various use cases that we've identified are here. Database conversion, that would be the SFPUC project I described. Accelerating of production, that would be the last case study we just covered. We've seen this make a difference with QA/QC and submittals as well as operator training. We've done cross-bore safety audits as well using our AutoCode technology. And then also we see a lot of benefit to folks who have projects where there's different stakeholders that need to collaborate, whether it be a third-party engineering firm, the agency itself, or the contractor or multiple contractors, especially if you're lining the pipe. And then don't have enough time to get into this right now, but there's quite an opportunity here for data analytics, for decision support or project execution, because we have this one central hub that's ingesting tons of data. And because of AI, is able to be very consistent in how it analyzes the data. So we expect that there's a lot of opportunity for getting insightful analytics as a result too. And I appreciate everybody's time. Now we're going to open it up for questions and answers. Thank you so much.